Page 664, section 11.1 is on simplifying rational expressions. So rational expression is in this form. Basically, it's a fraction with a polynomial in the numerator and a polynomial in the denominator. One thing is we're going to try to simplify these. Just like simplifying fractions, we can divide out common factors, or another way of looking at it is reducing by common factors, which is things that are being multiplied together. And with fractions, we've talked about that our denominator can't be 0. So a value that would make the denominator 0 is an excluded value. Okay, so excluded value, we could say it would make the denominator 0. Okay, we can't divide by 0, so those are going to be excluded values that we have to just say up front. We have to just say these are excluded values. These are values that the variable could not equal. And when you do that, you have to look for those before you cancel like factors. So at the very beginning, you need to look for what would make the denominator 0. Those are your excluded values, and then you can start trying to reduce. And again, the key thing here is, when you guys are doing this, is that factors can be reduced. Like I said a minute ago, factors are things that are being multiplied together. So what happens sometimes when we go through this is people have the wrong idea about canceling things out. So they'll say, like we've got 3x plus 4 all over, let's say x plus 7. And then they'll look at that and they'll say, oh, they both have x's. Let's cancel out the x's. Well, the x's are not factors. Those aren't things being multiplied. There's things being added in the numerator and in the denominator. So those are not factors, and so therefore we can't reduce those. And we'll talk more about that as we go through this. All right, so if you look at problem 1, they're asking what is a simplified form and state any excluded values. So before we even get started, we can look for the excluded values. Look at your denominator, and basically we can say the denominator cannot equal 0. So it's kind of like solving an equation, only instead of equals we have not equals. So if you add 5 on both sides and then divide by 5, then you'll see x cannot equal 1. So that's our excluded value. X cannot equal 1. And then after we've got that, then we can try to simplify this. In order to simplify this, we need to have things that are multiplied together, factors that are multiplied together in the numerator and denominator. So what we need to do is find common factors. In the numerator, x minus 1, there's no common factors. There's just a variable and a number. And they have nothing in common unless you want to say they have a 1 in common. That's fine, but that's not going to help us out. In the denominator, though, those both have a 5 in common. So if you factor a 5 out in the denominator, it's 5 times the quantity x minus 1. And that's helpful to us because in the numerator, we had x minus 1. So in the numerator, we could, if we wanted to, put a 1 in front of that x minus 1. Because what's going to happen is we are going to be canceling our x minus 1 factors. And it'd be good to have a number still in our numerator. Otherwise, we just cancel it, and it's like, well, there's nothing there anymore. So we can put a 1 there, and then you reduce, and then you end up getting 1/5 after canceling those factors. So the simplified form would be 1/5, and again, our excluded value, x cannot equal 1. So if you look at the got it, number 1, they want us to simplify and state any excluded values. So just like we did, and like I said, I would recommend at the very beginning, before you forget to do it, I would go ahead and look for excluded values. So excluded values, basically we're saying our denominator cannot equal 0. You might look at that and you might say, well, we haven't done anything really much of a cubed and solving for a cubed. That's okay. It's close enough to what we've done. You guys can figure this out. So first thing, we could divide by 7, which would say a cubed cannot equal 0. So at this point, a is being cubed, so we can take the cube root on both sides. And cube root says what times itself 3 times would give us that number. Times itself, so 0 times 0 times 0 is 0. So cube root of 0 is 0. So our excluded value is a cannot equal 0. This problem, a little bit different than the last one, is if you'll notice there's no addition or subtraction in these numerator denominator. So everything actually is a factor at this point. Everything's just being multiplied together. So we're going to try to look for some common factors that we can reduce. So with the number part, with the 21 and 7, we can reduce those both by 7. And that would be 3 over 1, or you can just cancel and say there's just a 3 in the numerator and the denominator. It just cancels out. And then with the variables, a squared and a cubed, those both have a squared in common. So where do we have more a's? We have more a's in the denominator. How many more factors of a we have? We have one more factor of a. So this looks a little odd, maybe like that. You could rewrite it as just 3 over a. If you put 3 over 1a, that would be fine also. And again, our excluded value is that we have to make sure they understand a cannot equal 0. Part B, once again, we have a expression that's got addition in it here. So in the denominator, that's not factors. So don't try to do any canceling yet. In fact, before we even think about anything with that, let's look for excluded values. So let's say our denominator can't equal 0. So to solve this, we would subtract 8 and divide by 4, and that tells us d cannot equal -2. That's the thing we got to watch for, is remembering to put not equal as we go through that. So that's our excluded value, and now we're going to try to simplify this. So in the denominator, numerator is a monomial, so there's nothing we can do there. In the denominator, we could factor out a 4. So that'd be 4 times the quantity d plus 2. Now we have factors. Now we can try to reduce factors. Now understand, with factors, if you have something in parentheses, we got like this force field deal here, you can't cancel unless there's another d plus 2. There's a d plus 2 in the denominator. If there's not a d plus 2 in the numerator, you cannot cancel anything out with that. So actually the variable parts we're not going to be able to cancel on this. We can look at the numbers. So with the numbers, 18 and 4 are both even numbers, so we can reduce both of those by 2. And that's going to be it. So not very exciting maybe. We couldn't do a whole lot of reducing on that one, but that's all we can do. You can only do what you can do. So that would be our answer. This to me is fine. This is simplified fine as far as I'm concerned. The book has a slightly different answer. And actually, if you distribute the 2 in the denominator, that would give you the answer that the book has. So they have this 9d squared over 2d plus 4 as their answer. To me, that's doing more work, and I think it's fine. It's already reduced as much as it can be the other way, so I would accept either one of those. But just understand, if you see the answer in the book and it looks a little different, you might try distributing and see if you get the same answer that they have. So look at part C. Let's start with our excluded values again first. So just say the denominator cannot equal 0. When you work that down, at the end, we've got a fraction, so you can reduce that. And I wouldn't worry about changing it to a decimal or a mixed number. You can just leave it d cannot equal 3/2 is fine. So that's our excluded value, and then we're going to try to simplify this. If you'll notice on this problem, right now we don't have any factors. Okay, you can think about there being parentheses around the numerator and parentheses around the denominator. Unless you see something else that's exactly what's in the parentheses and the other part of the fraction, you cannot reduce that. So in the numerator, there's actually nothing in common. So I'm just going to rewrite that. I'm going to keep it in parentheses so I'm not tempted to try to reduce it with something it can't reduce with. In the denominator, the 6 and the 9 both have a 3 in common. So that'd be 3 times the quantity 2n minus 3. So if you'll notice at this point, the numerator and the denominator both have a factor of 2n minus 3. I can cancel that out, but I need to also think about that I need still to have a numerator. So if you put a 1 in front of that, 1 times anything is going to keep the number the same. 2n minus 3's cancel, and that leaves us with 1/3. So it reduces to 1/3. The restriction on that is that n cannot equal 3/2. If n would have equaled 3/2, our denominator would have been 0, and then basically it would have been an undefined expression. We go to part D. Same idea. We're going to look for excluded values here first. So denominator can't equal 0. We subtract 7. Divide by 2. You can leave that as a fraction, or you can divide that out. Okay, and backing up here for a minute, I did put equals instead of not equals. At that point, they're squaring it, so we could do the square root. Square root of a negative number, that doesn't work. That's imaginary numbers you learn about in high school. So actually what that means then, excuse me, that means we have no excluded values. There are no excluded values. So C could be equal to anything and we'd be okay, which makes sense if you think about it. There's no way our denominator could equal 0 because we have C squared, which is going to be a positive number, whether C is positive or negative. You multiply it by 2 is going to be a positive number. You add 7 is going to be a positive number. There's no way we can get that to equal 0. So at this point, we're going to try to factor this because right now, remember our force fields here that protect us from reducing anything down. Right now, those don't match. So we've got to try to factor some things out, see if we can get some matches here in the parentheses, or maybe in front of the parentheses. So in the numerator, we can actually factor out a 13. We can also factor out a C, and that's going to leave us with 2c squared plus 7. Oh, that looks familiar. Okay, so if you don't have an idea, those numbers are maybe a little less familiar in the numerator. If you're not sure what that's going to work with, you might just think about in the denominator, 2c squared plus 7 we can't factor anything out of that at all. So what I would do, I would try to put the 2c squared plus 7 in the numerator and think about, is there a number I could factor out of that that would give me just 2c squared plus 7. So then you could say, well, to get, what would I need to multiply 2 by to get 26? And then you'd figure out that's 13, and then that would lead you into factoring out that 13c. At this point then, now if you'll notice, we have things in parentheses that are identical. We can cancel those. Unlike with the numerator, we really don't care if we don't have a denominator. You can put a 1 there if you want, but 13c divided by 1 would be the same as 13c. So 13c would be our simplified answer, and there are no excluded values for this problem. Problem 2, they want us to simplify this. What's different here is we have a trinomial instead of a binomial, and so we're going to have to potentially go into factoring that out into 2 binomials. If you look in the numerator, they factored that out as 3 times the quantity x minus 2. 99% of the time, they're going to give you something that at least part of this can cancel out. At least some of the factors can cancel. So when I see that x minus 2 in the numerator, I'm going to automatically just put an x minus 2 down here and then see if I can get something else to work with that. So it's kind of like they're not 100% guarantee, but almost a guarantee that they are giving you one of your 2 binomial factors for your denominator here. And that does factor that way, and then at that point you have x minus 2's in parentheses you can cancel, and then that gives you your answer. One of the things they didn't talk about was excluded values. Excluded values might be handier after we factor the denominator in this case. So if we say that can't equal 0, it's kind of like if we were solving an equation and we said, this times this equals 0. It's kind of the same thing. We say each of those factors, neither one of those factors can equal 0. And then that's where they got the x can't equal -3 and x cannot equal 2. So those are the 2 excluded values for this problem. So if we look at the got it 2, they were wanting us to look for simplified forms and stating excluded values. I know I talked to you about looking for excluded values right away, but sometimes on these it might make it easier for you to factor and find your excluded values first. So on A, in the numerator, I'm going to try to factor that. That's going to be easier to factor than the denominator. So if you factor a 2 in the numerator, that would be 2 times the quantity x minus 4. And then my 99% guarantee is that we're going to have an x minus 4 factor in the denominator. And then it's just a question of what our other factor is. I went ahead and just put the x minus 4 kind of underneath the other x minus 4, because if it's there, then I'm going to cancel it out. It doesn't matter. It doesn't have to be in that position. But so our other factor here would be x plus 2. Now what we need to make sure we remember is that we need to still say our excluded values. So our denominator can't equal 0. So if you solve those out without doing every single step of that, x can't equal negative 2 and x can't equal 4. So negative 2 and 4 are excluded values. And then we have x minus 4's in parentheses and their force fields that we can cancel out. And then that's going to leave us just with 2 over x plus 2. At that point, you don't technically have to, but I would recommend that you keep the x plus 2 in parentheses so that you can see the force field that is not going to allow you to reduce the 2's down. So remember, 2 is not a factor in the denominator. You cannot reduce that. So that would be your final answer. So if we look at part B, similar idea. So again, it might be helpful. This one's not as big of a deal because we only have a binomial in the denominator, so it's probably not as big of a deal for us just to solve that out before we factor. If it's a trinomial, then it maybe is easier to factor at first. So that would say a cannot equal 1. And then if you have a binomial and a trinomial, I would recommend factoring the binomial, and then from there that might help you to factor the trinomial. So in the denominator here we can factor 3 out, so that's going to be 3 times the quantity a minus 1. And again, not a full guarantee, but pretty close to it, that we're going to have an a minus 1 factor in the numerator. And the question is, what is going to be our other binomial? So if we think about if we were factoring this, we've got a plus 2 at the end, and we've got a minus 3a. So our signs both have to be the same. They both have to be subtracting then for us to get a negative 3a in the middle. And the only other factor with 1 would be 1 times 2 to get 2. And then at that point then the a minus 1's can cancel. And again, doesn't have to be, but I would recommend just keeping the a minus 2 in parentheses so you're not tempted to. In this case, we can't even reduce anyway, but just so you're not tempted to do that if the numbers work with the numerator and denominator. Part C, same idea. This one we've got a trinomial in the denominator, so it might be good to go ahead and factor these first. Since I've got a binomial in the numerator, I'm going to go ahead and factor that. So we can factor a 6 out of that, which leaves me a z plus 2. So I'm thinking I'm probably going to have a z plus 2 factor in the denominator. So to get the 2z squared at the beginning, we know our other factor, we'd have to have a 2z. Everything's positive, so our sign has to be positive here. And 2 times 3 would give us 6. Now let's check our middle term and make sure that that works. We got 3z plus 4z. That's 7z, so that works. So then that denominator can't equal 0. Basically, either of those factors can't equal 0. And without going through all the steps on that, it's going to wind up z cannot equal -2 and z cannot equal -3/2. So those would be our excluded values. And then we've already done the factoring, so it's just a matter of canceling our like factors at this point. So if you'll notice, we have in parentheses z plus 2 that we can cancel on both of those. And that's it. So that would be our final answer. So part D, similar idea. The problem here, we've got a trinomial in the numerator and the denominator. So neither one's necessarily going to be easier than the other one. Although I like in the denominator everything's positive here, that's going to make that easier to factor. So that would be c plus 3 times c plus 2. And we can go ahead and do our excluded values before we forget. It's easy to forget to do the excluded values because we're so excited to work these problems out. So that would end up being c cannot equal -3 and c cannot equal -2. So those are excluded values. Then in the numerator, we still need to factor this. Since you have two factors in the denominator, there's not a guarantee. I mean, one of those is probably going to be in the numerator, but we don't necessarily know which one it is. So you might just factor this like normal. We need c's in both places. Since it's -6, we know we need a positive times a negative, and we want one more negative. So since we want one more negative, factors of 6, we got 1 and 6 and 2 and 3. We want one more negative, so we'll go with c plus 2 times c minus 3. And coincidentally now, we have c plus 2's in the numerator and denominator that we can reduce. And this would be our answer then. And even though those are very close to each other, there's nothing more we can do to reduce that any further.